Alright, these are your notes on interpreting graphs, and in this video we're going to learn how to identify and learn what these key features of graphs are. So we've got 6 things listed here. The first one are intercepts, and we've heard this before, like with slope-intercept form and things like that, but you can have 2 types of intercepts. You can have x and y intercepts, and essentially, for what we're doing with graphs here, it's where a function crosses an axis. Now it would be an x-intercept if it crosses the x-axis, a y-intercept if it crosses the y-intercept, so again, or the y-axis. So again, you have 2 types there, x and y-intercepts. And you may have more than one. You could have several x-intercepts, and you could have several y-intercepts. Now if you have more than one y-intercept, it's probably not a function, but if we're looking at a graph, you have both of those, and it's where they cross the appropriate axis. The next thing is a relative maximum, which essentially is a high point on a graph. Another way to think of it, and I'm going to group this with relative minimum, is a turning point. Okay, it's where the graph turns from either going up to down or down to up. A relative max would be a high point, so it would turn from up to down. And then a relative minimum would be a low point, and it's where it turns from going down to going up. All right? Now the degree is how many times it changes direction. The graph changes direction. And that ties into your relative maxes and relative mins, because those turning points are where the graph changes its direction. But essentially, you just have to count how many times the graph is changing, going up to down or down to up. And we'll look at examples where that will become more clear. The next one are zeros, and zeros are the x-intercepts of a function. Okay, so again, we had 2 types of intercepts, x and y intercepts. The zeros are only the x-intercepts, where the graph crosses the x-axis. Okay, and then the last thing is end behavior. And end behavior is what the ends of the graph are doing. And it's going to be the hardest one of these 6 things to identify, because you have to write it out. You'll be able to see whether the graph is pointing up or down, to the left and to the right on the ends. But there's a specific way that we have to write end behavior. We can't just say up or down. We have 2 end behavior statements, one for the right side of our graph and one for the left side, and they are almost identical at the beginning. Both of them start out as x, and we use an arrow for approaches. And we're not going to say left or right. What this first part means is the left side of the graph and the right side of the graph. So the first sentence we have here, or statement, as x approaches, we're going to say positive infinity. The reason we say positive infinity is because as x gets larger, those numbers will continue to get larger, and to the right side of the graph continues on to infinity. That's why we say positive infinity. For the left side, almost the same thing. As x approaches, but we're going to the left where the numbers get smaller, and they continue to get smaller, so we say negative infinity. Okay? So both of them look pretty much the same, just the positive and negative infinity. You need to remember that the right side starts with positive infinity, and the left side is as x approaches negative infinity. Now the next piece of it's almost the same also. F of x approaches, and this means what the function is actually doing. Is the right side of the graph pointing up or pointing down? Is the left side of the graph pointing up or pointing down? So both of them are going to have f of x, and f of x again just represents the function, what the graph is doing. And then we will fill in these two with either a positive infinity or a negative infinity. If the graph is pointing up on either the right or the left side, we fill that blank in with a plus infinity, a positive infinity, to symbolize it's going up, and as the graph continues to go up, the numbers continue to get larger, and then it goes to infinity. If the graph is pointing down, we fill it in with a negative infinity, because the bottom part of our graph of the y-axis is where the numbers continue to get smaller, and they go to negative infinity. So again, the right side and the left side, they're almost identical. There's just a few differences. Both of them start out as x and then a line or an arrow approaches, and then the right side is plus infinity, the left side is negative infinity. Both of them have a comma. The second piece of the statement starts out the same way also. F of x approaches, has an arrow, and then we fill in that blank with whatever the right side or the left side is doing. Going up, a positive infinity, going down, a negative infinity. And on your graph, those can be doing different things. They don't have to be going the same direction. We've got 3 examples here, and we're going to identify all of those things. The intercepts, the relative max, the relative min, the degree, zeros, and the end behavior. So let's start with our first example. We'll start with intercepts. If we look here, our graph crosses the y-axis once, so we have one y-intercept. It also crosses the x-axis once, so we have one x-intercept. We have one of each, and that's fine. Now I'm going to skip down in our row a little bit to zeros, because again, zeros are the x-intercepts. Well, we only had one x-intercept, so we have one, and we're going to classify this as a real zero. Okay, has one real zero, 1 point where the graph crosses the x-axis. There is no high point and there is no low point here. Remember, the turning points are the relative max and relative min. This graph doesn't turn anywhere because it's linear. It's going one direction. So there is no relative max and there is no relative min. Again, because it's not turning directions, it's not changing directions at all. The degree here, it's going one direction. It starts at the top, it's going down to the bottom right, it's moving one direction here. So our degree is 1. And then the last thing is our end behavior. We're going to write our 2 statements as x approaches positive infinity, f of x approaches, now this is the right side because x is approaching positive infinity. F of x this is the right side, and it's pointing down, so I'm going to fill that in with a negative infinity. The right side of the graph is pointing down. I have to do the left side also, as x approaches negative infinity. This is the left side because x is going to the negative infinity to the left side of our graph. F of x approaches, well, the left side of our graph is pointing up, so I'm going to fill that up in with a positive infinity, and that would be our end behavior. And those are the things you're expected to be able to pull to interpret from a graph. Let's look at example number 2. Okay, now example number 2 is a quadratic graph. Okay, we've learned that before. We've seen that. It makes that parabola shape. So let's list out our key features here. Our intercepts. Well, that graph crosses the y-axis once, so it has one y-intercept. And it crosses the x-axis twice, so it has 2 x-intercepts. I'm going to go right to zeros now because, again, the zeros are the x-intercept. We have 2 real zeros because that graph has 2 x-intercepts. The next thing is a relative max. And if we look at our graph here, there is a turning point, but it's not a high turning point. It's a low turning point. So there's no relative max here, but there is a relative min. Okay, one relative min. And it's right here. It's that turning point. And in a parabola, that relative max or relative min has a special name. It's called the vertex of the parabola. Okay, something else to remember. The degree here is how many times it changes direction. So if we're looking, starts going down and then it goes up, well, that changes direction twice. So the degree here is 2. And then we have to list out our end behavior as x approaches positive infinity. This again is the right side of the graph. F of x is approaching. Well, the right side here is pointing up. So we would fill that in with positive infinity. Then we have to write the left side as x approaches negative infinity, the left side of the graph. F of x is approaching, well, it's pointing up also. So positive infinity. It is okay for both of them to be going the same direction. That's fine. Those are the things for example number 2. Now, example number 3 here, I want you to pause it and try on your own. See if you can identify these 6 key features, and then unpause it and check your answers. All right, now that you've had some time to come up with your own answers, let's go through what they are. Intercepts. Well, we cross the y-axis one time, so we have one y-intercept. We have 1, 2, 3, 4 x-intercepts. Go right to zeros now, because again, the x-intercepts are your zeros. We have 4 real zeros then. The next part, relative max and relative min. Max is a high point. We have one high point here, so we have one relative max. And the relative mins are our low points. We have 2 low points, so we have 2 relative mins. And then the degree, how many times it's changing direction. I am running out of room here, so degree I'll put over here. Our degree is 4, changes direction 4 times. And then our end behavior. Our end behavior is already written on here for you. So you already should have that, but check it, make sure you understand where it's coming from. Now, if you have any questions, make sure you bring them to class next time. And or you go back and rewatch the video, these are the 6 things that you're expected to know how to write. Again, the hardest thing I think is going to be your end behavior and remembering how to actually write that, remembering the statements, because they don't really change except for that blank at the end of them, what the left side is actually doing and what the right side is doing. You fill in that blank. So look this over, bring your questions to class next time if you have any.